Yeah, hi, good morning everyone. So today we will discuss with a new tool that is Git. Before that, we will quickly revise what we had discussed in the last session. So we had completed a shell scripting part. So we saw how to check the disk space, also how to alert if some systems are more than say X number. So we had decided to take 10%. You can also change it as per your requirement. So let's say if any of the systems are occupied more than 80%, then you can just show a warning over there. We had created a small program which can find and replace words from a file. Okay, so you have to just mention the file name, the word that you want to find, the word that you want to replace, and it is done. Okay, it will find and replace the words for you. So that was a very good program that we had created yesterday. Also, we discussed how to backup the files, right? How to create a tar. Do you want to create a zip? Okay, gzip of it. Okay, that option we can give to your customers or your users. And once that is done, it will create a tar file or it will create a zip file. Okay, so that entire program I have given it to you yesterday. Okay, it is a very simple thing. We are just using the tar and gzip command and we are taking the input and accordingly we are making the decisions, right? And also we had discussed how to copy the files across clouds. So for that we had created one EC2 instance, and from our existing EC2 instance we had copied the file to another EC2 instance, right? So how to copy files across EC2 instances? As I told you, this can also work on Azure or GCP. So if you want to copy files from your AWS EC2 instance to your Azure, that can also be done. Okay. So, in case if you know how to create Azure virtual machines, you can create them and you can try it. Okay, so only thing that there the username changes. Rest of the things they remain same. Okay, so this program will work for Azure also. I'm not sure of GCP because I've not tried it, but I've tried on Azure. Okay, so this can support cross clouds. But at least for us, it can at least copy the files from one EC2 instance to another EC2 instance. So wherein you will be defining the key name, the source path, the destination username, the destination IP address, the destination path. You know where you want to copy the files. So if you mention everything, and if that is mentioned in the proper or if it is mentioned correctly, then it will copy the files easily from one EC2 instance to another. So I would just suggest you to go through these sessions, okay? And it will the more you practice it, it will become much more easier for you. Okay, it is very simple. It is only thing the only thing is that you have not practiced it. Okay, so once you start practicing, once you start revising this again and again, just repeat them. And Friday, Saturday, Sunday, we have again 2 3 days of time. So again, if you have not revised Linux, you can just revise Linux and shell scripting. It can be very much helpful, right? And even if you're not understanding shell scripting, that's okay, okay, because I have taught you more than what is required in DevOps. Even if you're not understanding everything, that is fine. Don't worry, because the later tools that we will be learning, Git, Ansible, Docker, Kubernetes, these are the tools that are very much important. Okay. So in case if you find difficulty understanding shell scripting, that is okay. That is totally fine. But still practice it. Okay. At least 20-30% of the shell scripting will be required for DevOps, and just practice them. Obviously, Linux commands are important, but as I told you, I have taught you more than that we use in our real time. Okay, so in real time we hardly use 30-40% of the commands that I have taught you. Okay, so this is what we had discussed in the last session. Today, as I told you, we will be starting with a new tool, that is Git. So the we can say foundational tool of DevOps is Git. Git is kind of the last tool that the developers use, and this is the first tool that the DevOps engineers use. Okay, so this is like this is the start for us. This is the end for the developers. So they will be pushing the code to Git. That's it. Okay, so the later stage from pulling up the code and building it, testing it, QA, and all. So that part needs to be taken care by us. That is that needs to be taken care by the DevOps engineers. Now, what is Git? So Git is a source code management tool. Okay, so if you want to understand Git, you should first understand what is a source code management. That is SCM. It is written in short. SCM. That is source code management. So here you can see, let me just pull out these words now. So the source is from where the code is coming from. Okay, that is what the source is. That is its origin, where it is coming from, right? Let's say, for example, the source of the river and all. So from where it starts, that is what a source is. And code is any code. So mostly, let's say we will be working on code, right? The developers will be working on several codes. They will be working on, let's say, several languages like Python or JavaScript or Node.js or .NET, and there are, Golang, and there are several such languages. And we need a place, okay? We need a place which can manage all this code uh, in a single, we can say, single place. Okay, so whatever code is there, several number there may be n number of developers that will be working in an organization. So all these should come together, and they should be integrated in a single place. That is what we had discussed when we were discussing about what is DevOps, right? So DevOps is a place which will be moreover collaborating the team. They will be using automation tool, and there has to be a common place where all these teams can work together. For example, so source code management, as I told you, it is like managing the source code. Whatever code that you have written, it will just manage the source code. Now let's take, for example, you have several developers in your team. So obviously in any organization there won't be a single developer that will be working. There will be a team of developers who will be working on writing code. So this is a team of developers, and they will be working collectively. They will be working together. So the main concept, basic concept of DevOps is to collaborate the team. You cannot make them work individually or like in an isolated environment. They should work collectively. They should work together. So to bring that togetherness, a tool was introduced, which was or let's say several tools were introduced, which were called as the SCM tools. That is the source code management tools. So when DevOps became more and more popular, these tools became more and more popular. So what were these SCM tools? So we have this first is the popular one, that is Git. Okay, we are already aware of this. Then we have uh, Perforce, okay, and we have SVM, and there is one more tool, that is ClearCase. Okay, so there is another tool that is called as ClearCase. So these are the several SCM tools that were introduced. And what was the purpose of these SCM tools? The purpose of these SCM tools was to give the developers or give the team a common platform where they can work collectively. The reason behind that is, why do we need a common platform? Because each and every developer will be working on their own file, or they will be working on their own code. So let's say this developer number one, he has written a file wherein he has written the code and all. And there is developer number two, he has also working on some different code. Then we have developer number three, he is also working on some different code. Developer number four, developer number five. But do they need to write different codes? No, they will be writing a single code. The client is single, the project is single. Why do they need to write multiple codes? So they will be needing a common file, right? They won't be needing separate files. They will be needing a common file, or let's say a common So let me take it as a common file only, wherein they will be writing the code. Now, when you have multiple developers and you have a single file, you need some management, or you need some, uh, you need a tool which can help them to work collectively. They are not working on different files. They are working on a single file. This is a common file for them, and here they are working on the code. So let's say this is the line which is written by developer number one. Developer number one, he has written a line, then followed by developer number two, and so on. So they need a place wherein they can work to collectively on a common file, or a common place where they can they can work independently also. The file is common, but they should have their own freedom to work independently. Okay, they should not have any interruption. Okay, so let's say one developer is working, the second developer has added some line, and the first developer is not aware of it. That should not happen. There has to be a, we can say, a flawless integration. Although they are working on a common file, they should have the freedom to work independently. Okay, they should be aware what others have made the changes, what others are working on, which line I should pick up, which line I should not work. So they should have a common understanding, or they should have a mutual understanding of what are the things that have been changed and what are the things that needs to be added, and they should have that freedom. So you may be aware of online Excel sheet, right? So online Excel sheet gives you a freedom wherein you can integrate with multiple people and they can work collectively on that single Excel sheet. Okay, that is a common example of how we can work collectively on a single file. So that is a web portal that that it has several we can say advantages. But when we are talking on Linux part, or mostly if you are talking on Linux, then you have several developers and all, and if they are working on a common file, then you need some tool. Okay, you need some place wherein they can work collectively on that single file. So to overcome this challenge, these SCM tools were introduced. Okay, and they became popular because in DevOps there was a rise of automation and integration and collaboration of the team. So that is the reason why these SCM tools became more popular, and Git is one of the most used SCM tools. Okay, it is the most popular, and it is the most used SCM tool. And why, we will discuss the reasons behind that. Before that, let us understand what is Git now. What is the background of Git? Now, who introduced Git? Right. So Git, as I told you, it is not the only SCM tool. It is one of the several SCM tools that are available in the market. But Git is very popular, okay, and it is preferred over the other SCM tools. Now, talking about the background of Git, Git was introduced by Linus, the same person who introduced Linux. So he worked on creating a SCM tool. So Linus Torvalds, the same person who developed Linux, he in the year 2005 he developed Git. So he became aware that we need a SCM, we need a source code management tool, wherein we can work collectively. Even multiple people, they can work on a single file. So in around 2005, the person Linus Torvalds, the same person who developed Linux, he introduced Git, and after that the Git became very much popular. So Git, when Git was introduced, they were working on a local machines. So let's say this is your local machine. Okay, so people were working on local machines, and he created this Git wherein they can work locally and even without internet. Okay, so if you are working together in a single place, even if there is no internet connectivity, Git will still work. Okay, so it was created in a way that it can work with multiple people. Multiple people can work collectively. or let's say collaboration of team was done, and they could work easily on a single file. Also, they can also work offline. Okay, so this, he introduced this thing that they should be able to work offline as well. That is how this is how Git was introduced by Linus Torvalds. So let me just open the presentation over here. Okay, and see here it is mentioned that it facilitates the collaboration among developers and other team members also. Now, so this is not only used by developers now; it is also used by us, with the DevOps engineers, so that they can pull out the code from a common repo and they can they can perform the next activities, whatever next activities are required that we can perform. So it works as a common place wherein the team can work collaboratively. So this is the background of Git, which was introduced by Linus Torvalds, and he introduced it in such a way that they can easily work on a single file, and it could also help them work offline as well. Now later on, some few years later, GitHub was introduced. So a few years down the line, after Git was introduced, a tool called as GitHub was introduced. Now, what was the difference between Git and GitHub? So the basic thing is that Git had a web-based interface. Okay, so you could easily go on the internet. You could open the account with in GitHub, and you can push that code over there. Okay, so that is what GitHub is. So it is just a web portal which is available on the internet. You can just go create your sign in and create your own account, and from there you can just use it the same way you use the Git, and you don't need to use commands and all. You can just directly push and pull files from the uh, web portal itself. So this was a web portal which is still available now, right? And this is where you can just push and pull your files from the web-based interface. Okay, so it was moreover, it just eliminated the use of Git commands, and you can directly push and pull files directly on that portal. But there was one more thing that was added on GitHub, that it had an integration with Git. So the GitHub was developed in such a way that even the Git should not be eliminated. Okay, so whatever local repository that you have, whatever local code that you have saved over here, that should also be that should also be able, like, people should also be able to push it centrally or to a central place, right? So that is what GitHub was introduced. It was introduced in such a way that people should be able to directly push or pull the files directly on a web-based portal, or they should also be able to integrate it with Git. So Git was introduced, a web portal, as I told you. We will see how to create account and all later on, but it is more of a portal wherein you can just directly push and pull files. But it was also created in a way that it should not eliminate the use of Git, because Git is, even today, it is very popular. It is used, so whatever local work that you do locally, you should be able to push it on a central place. So GitHub was created in a way that anybody in the entire world should be able to work together. So with the introduction of Git became again much popular. Why? Because moreover they were working in a limited, we can say, environment. So with Git, as I told you, you are just working on a single system, or let's say in a local area network, you're working just on a single local area network. But with the introduction of GitHub, what happened is, even if you're even if you are working on some let's say in a different region or a different country, you could easily push the code on a web-based portal, and you can just work collaboratively. Okay, so it is kind of a, let's say, Google Drive, which can be accessible from anywhere, right? So GitHub is like that. It is just like a Google Drive, wherein you can just push your code and you can access it from anywhere. So it is kind of a place, a drive for the team, which even if they are working in some different country, different region, they can easily push and pull the files across different regions also. So let's say if the developers are working in India and the offshore team or the on-site team is in, say, let's say US, then they can easily work even with the with the help of GitHub. They can easily work across different regions or different countries as well. So that is the reason why GitHub became more popular. Okay, so it was kind of a web-based interface. It was a portal. You had to just sign in to that portal, and from there you can easily pull or push your files seamlessly, okay, with the help of Git. So it was made in a way that it should be integrated with Git also. So the developers, they are working on their machines, and this is, let's say, their local repository, which will obviously be within the local machine only. So let's say this is their local repository. So they are pushing and pulling the files within their local repository. So the team from India, they are pushing the files in their local repo. They are pulling the files from the local repo. Not only that, after they have confirmed that these push and pull is okay. So let's say they have pushed files in their local repository. That means they are Git repo. And if they find they have reviewed the code and everything looks good, they will just push that code to their central repository, that is the web-based portal. From this portal, the offshore team will pull the code, and they will again, if they want to make any changes, they will do it locally. And if they are confirmed, if they have reviewed the code, and again they will push it back to the central repository. So this GitHub over here is also called as a central repo, or let's say central repository. So this GitHub is also called as a central repository wherein you can store your code centrally. Okay, because as I told you, it can work cross region. Even if your team is working in some different region, it won't matter because it is stored as a central repository. And this place, like in your local machines, when you are pushing and pulling the code locally, this is called as a local repo. So this Git is called as a local repo because we are working locally, right? Okay, so this is how the Git works. Okay, so you will be first working locally on your local repository, and once you are confirmed with the changes, you will push it centrally, and from the central place, your team, let's say offshore team or DevOps team, they will be pulling the code from here. So even here from here, the DevOps team will also pull the code. So let's say this is the DevOps team, they will also pull the code from here. So it is kind of a central place, from where multiple teams can pull or push the code. Not only they can pull the code, they can also push the code over here. They can also store their code also over here. So, multiple teams, the DevOps team, let's say the testing team, the QA team, they can have a central place. Once the developers are confirmed with the changes, they have reviewed the code looks good, they have pushed it centrally. This code can be further pulled out by the on-site team, by the DevOps team, by the QA team, by the testing team, and by the rest of the teams, your managers, your higher management, whoever wants to review the code, they can easily review it from the central place. And here, let's say in India, there are, let's say, hundreds of developers that are working. Okay, even that makes no difference because we are working on a single file. So this single file can be reviewed centrally in a single place, in a central place, from where each and every team can work or they can access the code, right? So this becomes much more easier when we are working in a team. Okay, so if you are working on a single project, okay, so all these project files, they should be stored centrally, and you should be able to track all the changes that you have done, who has made the changes, right? Now see, when you are working in teams, there are multiple people that will be present in your organization, right? So as I told you, there will be multiple people who will be working together. Now, one challenge that comes when we are working collectively is, how will you identify who has done what changes? Or how will you identify, like if somebody has deleted a line or if somebody has added a line? So let's say if you're working on, we have these developers, developer number one, developer number two, developer number three, developer number four. So let's say, let's take it only four developers. So let's say there are four developers who are working on a single project. So let's say this is a project, and they are working on a single project. Now let's say developer number one has added a line, then developer number two has also added the line. Then how will this developer number three and four get to know, come to know? So you need a place, you need a common place, and you need to know that each and every developer should be aware what are the changes that have been done. And let's say this developer number three and four, they have just changed this code. So instead of writing developer number one and two, they have just changed it to developer number three and four. So how will you be able to identify who has made what changes? So when you're working collectively on a single project, it becomes a big challenge to identify which person has committed what things. Okay, so it becomes very much challenging to identify the changes that have been done by others. So that is what has been resolved in Git. So in Git, you can track all the changes. So Git will help you to track all the changes. Even if somebody has added a dot, or a comma in the code, even that will be recorded. Okay. Even if somebody has added a space, even that will be recorded. If somebody he has removed a single letter from the code, that will be identified. And that initially you will be needing to do the configuration. Whenever you install Git on your local machines, you will be needing to do the configuration. In the configuration, you will be needing to mention your name and your mail ID so that Git can identify you. And after it has identified you, your whatever changes that will be doing in this project, in this common code, that will be tracked by Git. So whatever name that you give in the beginning when you'll be doing the configuration, Git will store that name, and that is the name that will be recorded for each and every changes that you'll be making here in the code. So one advantage of Git is that you can record each and every changes, or each and every minute changes, I would say. Even if somebody has just entered a backspace and saved the changes, that will also be recorded. So that is how Git is useful. And let us discuss the several features of Git, or rather why we need to use Git. The biggest advantage of Git is when Linus Torvalds, he developed Git, he made it again open source, same as Linux. So Linux is open source. He also made Git as open source. He did not. You can easily pull out the package from the internet and you can just download it in your machine and you are good to go. There is no need of any subscriptions or any payments. Nothing. It is free and it is open to all. The updates are free. The installation is free. Everything is free. So it is open source. First of all, anybody can go and download it. Second is it is free. Anybody can install it in their machine without any upfront payment, without any charges. So one biggest advantage that we have with Git is that it is free. You can easily go and pull out, download, install, upgrade, anything you can do. Okay. Second thing, it is just secure, obviously. So Linus Torvalds, when he made Linux, he made it secure. Similarly, he made Git also very much secure. Okay. Third, as I told you, we can track all changes within that is happening in the Git. You can track each and every changes that you do inside Git. Second, or the other reason of why we will be needing Git is that it is compatible. It is compatible with other source code management tool. So, for example, it is compatible with GitHub, with other Purpose and SVM and ClearCase. So, other does what we say other source code management tool, they are compatible with Git. Okay, so you can easily use Git even if you are having a different central repository. Okay, so it is also, it can be integrated with GitHub, GitLab, Bitbucket. So these are the tools that are also work, parallelly along with GitHub. So instead of GitHub, we have GitLab. We also have Bitbucket. Right? These are also kind of source code management tool with some advanced features. So they have some added features as well. And the most important part is that using Git, you can work offline. Okay, and this system is called as a distributed version control system. Now, you may be thinking now, what is a distributed version control system? So let us discuss this. Okay, so these are the several features of Git. So you can just use it as an open source. It is free. It is secure. You can track all the changes. Okay, it can support all the different platforms. You can work offline. And also one more part is that there is another concept called as branching or let's say branching. You can do the branching. We will discuss what is branching. And before that, let us discuss what is DVCS and what are the different types of version control systems. So basically, we have two types. One is the DVCS, that is the distributed version control system. DVCS, it is written in short as DVCS. And the second that we have is a central version control system. Now, this is sometimes asked in interview, very rarely. When you say that you are aware of Git, they may ask you, but it is a very rare question that is asked to differentiate between a central version control system and a distributed version control system. So we have the CVCS, it is written in short as central version control system and a distributed version control system. So Git comes under this. Okay, so whatever diagram I have drawn over here, I'll just pull out the same, and this is what distributed version control system means. Okay, so this is the same diagram that means this is a distributed version control system. So what happens over here is you are first pushing the code locally. Okay, so you can just work offline. You have a back copy of your code over here and another copy you have over here. So you have two copies. So that is a distributed version control system, right? You have distributed your code across different systems. That is what distributed version control system is. So you have your local repo, you have your code safe in your local repo, you also have your code safe in your central repo. So that is what a distributed version control system is, and the best example is Git over here. So the best example of Git, it is a tool which uses a distributed version control system. Now let's come back to the central version control system. So here, what happens is this local repo is eliminated. So directly from your systems, you will be pushing or pulling the code centrally. Like for example, Google Drive, right? So from our machine only, we'll be pushing the code, and if we delete the file from our local system, it is gone, right? There won't be any. You won't be able to save your files in locally. So this is kind of a central version control system, and for this we have an example called as SVM. So SVM is a tool same as Git, but it uses the central version control system. So this question is very rarely asked, but you should be aware what is the difference between DVCS and SVCS. Sorry, CVCS. So the reason, one of the biggest feature or the benefit of using Git and GitHub is that it supports the distributed version control system. So not only you'll be having a backup of your code centrally, you will also be having a backup of your code locally, okay, in your local machine. Now coming back, told you we will be discussing the branching later on, but before that, let us understand the Git architecture. So how Git works and what are the different segments in Git. So whenever you're working in your machine, so let us discuss the Git architecture. Okay, so when you are working in your machine, and the moment you install Git in your machines, then what happens is inside your machine, three virtual sections get created. Okay, so you cannot see these sections, but Git will create three different sections. So let's say this is a one section, section number one, section number two, and section number three. So these are three virtual sections or virtual segments that will be created the moment you install Git in your system. So this is not visible, you cannot see them, but this is something that is created virtually. So the first section over here, this is called as the work directory. So this section, the first section over here, this is called as the work directory, and this will be the directory where you will be currently working. So whatever commands that you will be running, and whatever files that you will be creating, everything. So it's kind of a let's say directory you are wherein you will be currently working on. Okay, so this will be your current working directory wherein you will be making the changes, you will be working on the code. So this is just like a simple plain directory wherein you will be writing all your commands. After this, other section that we have is called as a staging area or the index area. This is called as a stage or also called as the index. So this is just a platform wherein you will review the code before further pushing it to the local repository. So this over here, this is called as a local repo. So it's in simple words, let's say work directory is like, it is like a manufacturing industry. Let's say you are, if you visit a manufacturing, or let's say if you have seen a manufacturing industry, you may have seen that there is a shop floor wherein they will be doing the manufacturing. Okay, they will be joining the parts, they will be attaching, they will be doing the painting, right? So and doing, they will be doing everything over here. So this is kind of a shop floor wherein they will be assembling the entire car. Staging areas wherein before sending the car to the showrooms or for the use of customers, they will be first testing that car or that vehicle within their own premises. Right? They have a track, they have a test track wherein they will be driving the car within that test track. They will be just ensuring that the car is, um, you know, it is good for further use. Okay, it is in a way that it can be used further. Okay, so they will just review it. Okay, they will just check the quality. They will do the we can say they will be first reviewing it. They will be doing the test drive here. Once this is tested, once the test drive is done successfully, they will be further sending that cars to the showrooms and let's say to the customers and further on. Okay, that further process will be done. Similarly, in when you are working on code, this is where you will be writing the code. So this is the stage where you will be writing or editing or changing or deleting some code. So here you will be doing the add, let's say delete or modify of the code or the files. Not only code, this is related to files also. So here you will be adding, modifying or deleting the file or directories, whatever. You can work on files, directories. So everything you'll be doing over here. After you are done, you'll send it to a staging area. So you are sure that this has worked properly. Now this is done properly. Now you will send it for further review. Okay, so this is the area, this is the staging area where the file will be reviewed whether everything is done properly. So this is just like a review area. So this will be just reviewing the file or the code. Okay, this is where you'll be reviewing the file or code. And after once you are done, once you are satisfied, okay, the file is proper, the code is proper, then you will be storing it or you will be pushing it to the local repo. Once the code is pushed to the local repo, it's mean that it has been committed. This is called as a committing the code, or let's say simple pushing the code. Now we will be using the word commit. Okay, we will be using the word over here as commit. So I will write it as commit, or let's say simple words pushing the file. Now what is a commit? So commit is nothing but simply creating a backup of your file. So that is what commit means. So you have your file, or let's say you have several files, and so once you have done adding, reviewing, done, and once you do the commit, it will create a backup of your file. So it will create it like this, a single backup of your file. This process is called committing. That you are just pushing the file and you are creating the backup of all these files along with all the changes. So this process is called as committing. So in the work directory, you will just add, modify your files. In the staging area, you will review your files, and after that, you will commit your files. So once the commit is done, you won't be able to make any further changes. So that is the reason why a staging area is added here, so that you first ensure that everything is in a proper condition. Everything has been added, edited, modified properly. Once the review is done, you can just push it to the local repository. So this is called as committing. Okay, this is what you call it as a commit. And this is how a Git architecture is. So the moment you install Git in your systems, it will create three virtual sections. One is a work directory, second is a staging area, third is a local repo. Now, after this, we have another place. So this is your local repo, but if you want to, let's say you want to push it to GitHub. So that is a central repo, right? So from here, you can push it to your central repo. So this is like GitHub. So this, let's say, local repo will be called as Git, and this will be called as a GitHub. So from Git, you will be pushing the files to GitHub, which will be stored as a central place. So all these files over here that you have, whatever code, whatever files, whatever directories that you have added over here, you have reviewed in the staging area, you have stored it in the local repo. You will just push it to the central repository that is on GitHub. So GitHub is kind of a central repo, and here this is the local repo. So you're just pushing the code outside of your systems, local systems, to a web-based portal. Okay, so that portal and all we will be seeing. Don't worry. And just give me 1 minute. Okay, so this is how this one over here. This is the Git architecture. So this is how Git. Once you the moment you install and configure Git, three virtual sections will be created. This is how it is. Okay, this is how the Git architecture is. So there will be a work directory, there will be a staging area, and there will be a local repo. And there will be some commands that you will be needing to use to transfer these files from the work directory to staging area and from the staging area to the local repo. So that we will see later on. So that is called as add, commit and push, that we'll see later. Now this is the Git architecture and the Git flow. So this is how the code will be it will be flowing from the local repo to the central repo, right? And from again here you can also pull the code, or rather let me write it here like this. So let's say one developer is working on a machine, there is another developer who has worked on some different code. So before writing a code, what he will do is he will first pull the changes that you have done. So let's say this is developer number one, this is the machine of developer number one. He has pushed it centrally in a central repo. After the changes have been done, this developer number two will first pull all the changes. He will make his own changes. Again, he will push it back to the central repo. Now the developer number one. So let's say, for example, let's say, suppose that the developer number one is working on the day shift in the day shift. Developer number two is working in the night shift. Developer number one has created a new file or new project. He has done all the changes, pushed it on the central repo, and he has completed his shift. Now in the night shift, developer number two will come. So before work doing anything, first thing that he will do is he will first pull the code. Okay, he will pull all the code which the developer number one has worked on. He will make his own changes and he will push the code. So his shift has his shift has completed. Again, developer number one will come, with a new shift. So he has come on the day shift. So before working on the previous files, what he will do is he will first pull all the files that are there in the central repo. So he will have file number, his own file, along with the files of this developer number two, right? So this is how it works. So let's say this is the developer number one code that has been pushed here. Now same developer number one code will be pulled over here by the developer number two. The developer number two will make his own changes. Then the code will be of developer number one plus developer number two. It will be a combined code, right? And this developer number one and developer number two code will be pulled again back by the developer number one. So this is how they will be working together, right? They will be working across local and central repositories like this. So this is what a Git flow is, right? This is how they will be working across the local repos and the central repository. Now, moving ahead, we have discussed Git, GitHub, why Git. We have discussed the version control systems. We have discussed the Git architecture. This is how the Git architecture will look like. So the moment you set up Git, you will have a workspace, you will have a staging area, and you will have a local repo. Okay, so this is the work directory wherein you will be adding, editing, or deleting files. This is the staging or index area where you will be reviewing the files before committing. And this is where the place, local repo, which will store the project files and the previous history. So if you keep on adding files, it will store all the files along with all the history. And this will help you to work offline. Okay, so this local repo will help you to work uh, offline. And this is the Git flow. So from the local workspace, you will write the command git add, then it will be added in the staging area. You will review the code, then you will write the code, then you will write the command git commit. So this will push it to the local repo. Then you will write the command git push. Then this will push the files from the local repo to the central repo. So this is the GitHub. These are the commands that we will be discussing in the practical also. Now, the another important concept is the branch. Here we had discussed it, branch. Now, what is a branch and why this is used? Now, what is a branch and why this is required? Now, let's say you are working, so let's say these developers, they are working on the same files. So let's say this is a common file, and these developers, they are working together. And this single file is okay, it is working properly. So they are working like pushing and pulling. That is what they are doing over here. So from local to central, central to local. So this push and pull is done by these developers, and this is working correctly. So they are working on a project. Now what happens is all of a sudden the client comes and he suggests that I want two designs. He says that, in the application I want to check two different features, or let's say two different design. So let's say design number one, he wants to check the design number one, then he wants to check the design number two, and accordingly he will take a call which design to finalize. So these are, let's say, two designs, or let's say two features that he wants in his application. This is the client. Okay, and he wants to check two different designs, and along with that, whatever current design is ongoing, that should also be retained. Okay, that should also be there. He wants to check, he wants to see two different options. Along with that, the current design should also be there. Okay, he doesn't wants to miss the current design also, so that should also be continue. Whatever you are doing, it should be continued. It should not impact. Okay, so the current design should not be interrupted with these two options. Now when you are working here, you can see you are currently working on the current design. Now these developers, they will think that, how can we make changes, how can we work on multiple things, because this is kind of a central repository, or this, it will just store the code centrally. You cannot just create two multiple options or two different things from the local and central repository. So that is the reason why branch was introduced. So branch will help you to work on multiple things together. So let's say what they do is they are working on, let's say, in the current design. So this developer number one and two, they are working on current design, and they don't want to get interrupted. Okay, so they, what they decide, we don't want to get interrupted. What they will do is, from the current design only, they will create another, let's say, area, another, let's say a folder. Let's say from the current design, whatever code that they have written, whatever files they have written, they will just copy all these files here. Everything will be same, it will be copied here from the current design, and they will tell developer number 2 and 3. So let's say this is developer number 1, developer number 2. They don't want to get interrupted, and what, let's say their manager decides, okay, you continue your work, okay, don't get the current design get interrupted. Then what the manager will do, he will just give this task to developer number 3 and 4 to work on design number 1. So what the manager will do, he will tell, so see, we have design number 1, you design developer number 3 and 4, you work on design number 1. Okay, and whatever the client has asked, start working on that design. So they are working on design number 1, developer number 3 and 4, they will work on design number 1. And from here again, what we will do is, from the current design again, another, all the files will be copied to another area that is called as design number 2. So client wants to have multiple options, right? He wants to check the current design. He also wants to see design number 1. He wants to see design number 2. So this existing files we will be needing, right? We cannot just create it from scratch. We want the existing files. So from the existing files, we will just create another area and we will assign developer number 3 and 4 to work on design number 1, and the manager will assign developer number 5 and 6 to work on design number 2. Okay, so what will happen is they will now work on multiple designs and their work won't get interrupted. So this area, different section or different area that they are working on, this is called as a branch. So this thing over here, this is called as a branch. So this design one, let me call it as a branch only. And this design number 2 is another branch. So what branches help you to work, work in a way, or to have to work on other another features without interrupting the current feature. So the current features, the work will be done. It will continue to, they will continue to do your work. They will do their modifications. They will do their changes, and they will just show it to client. The client will see it from the current design. This is called as the current branch, or this is called as a main branch. Okay, so the main is a branch wherein mostly the current code or the 100% working code will be stored here in the main branch, and in the branches from where which you have separated out from the main branch, these are the other branches wherein you can work on different things. You can do your own experiments. You can, let's say you want to add new features, you can work on different things with the help of these additional branches. So this is what a branch means in Git. So branch is nothing but it is just a different area where you can work differently. Okay. So these two developers, they are working on the current design. These two developers, they are working on design number 1. These two developers are working on design number 2. And whichever they design the client likes, okay, whichever design the client finalize, they will just merge this to a single branch only. So that, that is the code that is used finally. So that is called as branch merging. Okay, so all this, what, let's say he has decided to go with design number 2. So whatever changes that you have done in design number 2, they will be added here in the main branch only. Okay, so that main branch will be used. Now, how does this branch, how do we work on multiple branches? Or let's say, what is the branching strategy that is used in organization? And this is one of the most asked interview question, that what can you explain the branching strategy? So each and every organization, they have their own strategy. But as a general terms, we will just discuss the general branching strategy that is used. So I hope so you have understood what is a branch, what a branch is. So branch is nothing but when you want to work on multiple different features or multiple different options, multiple different designs, then you can just pull out the branch from the main branch, right? And you can work on these branches. Now, one of the most asked interview question is, what is a branching strategy? Okay, how do you create the branches? What are the names that are given to the branches? And who works on which branch, right? Which team works on which branch? Is that is what we call it as a branching strategy. So the branching strategy is very simple. Whoever is a developer, they will be working on a branch called as a dev branch. So we will be having a branch. Mostly in several organizations, they will have a branch called as the dev branch. So this is my dev branch, and this is the branch with the developers will be working on. So the developers will work on this branch only. That is the dev branch. This is also called as the pre-production code. So before moving on to the production, whatever changes, addition, deletion, or modifications that will be done, this will be first done in the dev branch. From this dev branch, the main branch will get created. After everything is confirmed, after the code is tested, everything is working fine, everything is done, then a main branch will be created, which will have the 100% working code. So the main branch, it will ensure that it will have the 100% working code always, so that the code is not missed out. Okay, so this is how these branch will be created. From the main branch, the 100% working code will be stored, and another branch is there which will be only used for the customers. So if let's say you are working on an application, So there will be another branch that is called as the release branch. So there is a release branch which has the code, or let's say the final application code, or rather this is the code which will be released to the customer, or this is the branch that is specifically meant for the customer. And this main will be as at a central place. So every all the code will be all the branches will take, we can say, reference from the main branch. Okay, so main branch will always have the 100% working code. This is the release branch will be there for the customers. And there is another branch which is called as the hotfix branch. Now, the name itself means that we are just doing some hot fix. That means immediately we are doing something and we are just fixing it. So this branch is mostly created. So let's say you have released something to the customer. So this is your end client or your customer, and he has come up with a bug. He said that whenever he's trying to book something, he's not able to book it. So this is a bug. This is an error. So what will happen is this hotfix branch will be created from this release branch. Okay, the releases or the bugs will be fixed. They will be tested, and after the testing has been done, it will be sent further back to main branch from the release branch. Again, it will be delivered as version number 2. So previously version number 1 was not working, let's say for example, then version number 2 will be released with the bugs that are fixed. So this is kind of a which is already happening in the production. So while in the production, let's say they are not able to book something, the client, let's say, he will just identify that there is a bug, then immediately a branch will get created, which is called as a hot free fix branch, and this is a temporary branch. Okay, so this is just a temporary branch which is just used to fix the bugs. Okay, the once the bugs are fixed, they are tested, then they will be merged with this main branch and this release branch. So again, the main and release will be in sync. Okay, they will have the same code, and version number 2 will be created. Now if let's say the version number 2 is working fine, that's okay. Again, let's say in version number 2 there is some another bug. Again, that bug, let's say that bug has been identified. Again, this this will get created, this hotfix branch will be created, the bugs will be fixed. Again, it will be pushed back to the main branch and to the release branch, and another version will be released with the version number 3, let's say. So this is how the bugs are fixed. That is what we call it as a hotfix branch. So this process keeps on continuing until and unless all the bugs are fixed. And once all the bugs are fixed, this hotfix branch is, it is later on deleted. It is not required. So this is just a temporary time being branch that is created only to handle the bugs in the production code. Whatever you have released to the customer, if there are any bugs, then these bugs will be fixed by this hotfix branch, and again they will be merged back to the main release branch, and this will keep on working like this in the cycle until unless everything is fixed. And once everything is fixed, this hotfix branch will get deleted. You can just simply delete that hotfix branch. Now this is working fine. Now let us take an example, for example, of an Uber app. Okay, so we have developed an Uber app. So the developers have worked on that app. Okay, so this app was initially only for booking a cab, for booking a four-wheeler. So you have pushed the code, okay, and you have released the code to the customer. And the moment, let's say for the first time, the customer is facing issue booking the cab. So let's say we are working on Uber app, and what happens is whenever the customer is trying to book something, the cab is not getting booked. So there is some bug. So he reported the bug. You just created a hotfix branch. Again, you just released it in the from the release branch, and with the version number 2. Again, he found out some bug that we are able to book, but I am not able to contact the cab driver or something. There is some bug, or I'm not able to chat with the cab driver. Again, there is a bug. Again, you will create the this hotfix branch will get created. Again, it will be tested. Again, it will be merged back to the main and release branch, and version number 3 is created. And this Uber app with version number 3 is working fine now. Okay, now this is working fine. The customer is able to, they are able to book the cab. They are able to do all the stuff. So there is no some issue. There is no issue as such. So that means that the version number 3 over here that is stored, this is now the 100% working code. Okay, so this code is now working fine. Whichever that we have in the main branch, this code is working fine. Also in the release, the code will be working fine. So the release will have version number 3, right? And the main will also have version number 3. So the main will always have the latest 100% working code. So V3 version number 3 is working fine, and we have stored the code, and customer is happy, we are happy. But after some time, the customer has decided that along with the four-wheeler, I also want an application. I also want a feature in Uber wherein you can book a two-wheeler, right? Previously, it only had an option to book a four-wheeler. Now I want an option with a two-wheeler. No, this is a version number 3 which will support only four-wheeler, booking a four-wheeler. But I want an option. The customer comes up, he contacts the organization, whoever has developed this Uber app, and he says that, this is working fine, but I want an additional option wherein I should be able to book a two-wheeler. So he just suggests them, okay, if you want, you can just create another version, and we will just release the new version to the customers. So let's say V4, version number 4, which will have four-wheeler along with two-wheelers. So the customer should also be able to book a two-wheeler. This is an additional feature that needs to be worked on. So what the company decides is, from the main branch, they will create another branch, which is called as a feature branch. Now you may have understood the feature itself means that you will be working on new features. So you won't touch the main branch. You won't do anything with the main branch. The version number 3 is working fine. We don't want to touch that. Okay. We don't want to make any changes in that. We will just create another branch that is called as a feature branch. We will work on the features. So this feature branch already has the four-wheeler code, wherein we are able to book a four-wheeler. Additionally, the developers will work on creating, booking a two-wheeler. They will test the branch. They will test the code. Everything looks good. Then they will, if everything is looking good, then they will just push it to the main branch, and they will again send it to release. And from the release, it will be released as a new version. That is version number V4. Okay, so from the feature branch, this code will be pushed to the main branch. Now the main will have V4, the release will have V4, and the customer will be working on V4 only. So the customer will have an app with an update which is version number 4. And after that, you will also get notification on your Android or your Play Store that please update your Uber app. So the moment you update your Uber app, you will be able to see that you are able to book a four-wheeler. Also, you are able to book a two-wheeler as well. So this, again, this main release and feature will have version number 4. Now again, let's say there is some bug that was there. We are not able to book a four-wheeler. Again, they will be pushed to hotfix. Hotfix will make the changes. It will just release at a version number 4.1, let's say. So this is the fixed version. The changes have been fixed. It will be released from the release branch. Again, the version number 4.1 bit will be released to the customer. And let's say that version is working fine. Then this hotfix branch will get deleted. So this is just a temporary branch that will be created just to fix the bugs. Okay, if whatever bugs are there, these will be fixed with this hotfix branch. So this is just a temporary branch that will be created momentarily to handle the bugs in your production code. Once it is fixed, again it will be merged back to main release, and the code, you will be having the code, right? So whatever working that you will be doing, main will be at the we can say epicenter. It will be at the center. Okay, it will be like a common place. It will always have the 100% working code. From this only, you will be taking references. Okay, so from here you will be taking all the references. Now previously when Git was there, even in GitHub, the main name of the main branch was actually master. but later they just made some modifications and they decided to change the name from master to main. So even in some organizations, you may be able to see the master branch, but master is a old, we can say, concept that was used previously in Git and GitHub. Master was the primary branch that was used, but later on it was changed to main. So even when you will be doing the installation and configuration of Git, Git still uses the master branch as a primary branch. You have to change it to main branch, and after that you will be need to start working. If you create your account in GitHub, you will the main primary branch that you will see is the main. If you install Git in your machine, the primary branch that you will see is master. So master is still there for Git. Main has been updated for GitHub. So whenever we will be doing the practical, the first thing that we will be doing is we will be changing the branch from master to main. Okay, that we'll see this in practical. So this is a uh, overview of how the branching strategy works in any organization. So first it will be starting from the main branch, from the dev branch, where the developers will be working on the pre-production code. Then you will be having the main branch, which will have the 100% working code. Then you will have the release branch, which is the branch for the release to the customers. Hot fix branch is the temporary branch wherein you will be fixing the bugs. And feature is just a branch if you want to add any features. Okay, so if you want to add any features, then you will be needing to create a feature branch and you will be needing to work on that new features. Okay, so that is how I have shown you an example with the help of Uber app so that you can understand. So this strategy is sometimes different for different organization, but this is we can say a basic strategy that you can use. Most like almost 70-80%, this is the strategy that is used. But in some organization, they just add some other branches. They have the drop branch. They have some different branches that they create that is as per their requirement. But mostly, this is the five branches that are used in real time. Okay. So this is the about what is a branch, and this is what is a branching strategy. So we are done from the theoretical part of Git. Okay, so we have discussed the Git topics, the what is a Git, what is a source code management, what is Git, what is GitHub, why Git is required. This is the difference between the distributed version control system and the central version control system. This is the Git architecture. This is the Git flow, how you will be running the commands and pushing the code from local to central. This is what a branch is, and this is the branching strategy. Okay, so this question is asked in interview. So the moment you say that I'm aware of Git, the first question that they will ask you is what is the Git branching strategy. Okay, so the most asked interview question, what is a Git branching strategy? This will be asked like in 80 to 90% of the times in interview they will ask you to explain the branching strategy. So I'm done from my side. If you have any questions, then you can please ask, or else we will wrap up for today. And in the next sessions, we will start with the Git practical. All right, then I think there are no questions. So we'll wrap up today, and we'll meet again on Monday, and we will discuss the. We will start with the Git practical. Okay. Okay then. Thank you everyone.